Good morning, students. We will continue the previous class. In that previous class, I was saying you about the totally reflecting prism, and I was saying you about that first light ray, how it got entered into the prism, and how it refracted, and finally how it got emergent. So now here, this one is the incident light ray to that prism, and this one dash is the emergent light ray. You look here, this is incident and this is emergent. How much angle it got deviated? Instead of moving like this, it bent like this. How much angle it deviated? 90 degree it bent. See, this is light. Instead of going straight, because of presence of that prism, it moved like this. See how much angle it bent? It bent 90 degree deviation. This prism produced 90 degree deviation because of TIR phenomena. So that's why we called it as totally reflecting prism. How much light got entered into the prism, same amount of the light got emitted by the prism. That's why title we called as totally reflecting prism. Without loss in the energy, that medium refracted that light ray. That's why we call totally reflected. That is because of TIR. So we call this is also an application of that TIR. This is about first light ray. Same thing we have to imagine with this is second light ray. This is second one. Got incident here. This is normal incidence. Kept moving along the same path. Again it got incident here. It came from denser medium and bounced back to the denser medium. Here what happened? TIR happened for this second light ray. Yes, this light ray again came here. It got incident here. Again here. See there, this light ray hitting that surface normally. So it keeps moving straight. This is the emergent light ray called 2 dash. So 2 is the incident and 2 dash is the emergent light ray from that prism. So now here this also went by 90 degree. Yes, same analysis. Now what happened here in this second diagram? What we did here, just in here we placed that prism like this. Here we placing like this. Position we going to change. By changing the position or orientation, we going to get more deviation. How much deviation we got in this position? 90 degree. But here we will be getting 180 degree deviation. See here, light ray came, something happened, again came like this. Instead of going straight, it came back. How much? 180 degree deviation we getting here because of TIR. Yes, that's why it is a part of its application. So now look on this prism. This is also totally reflective prism. Now look here. This is our first light ray. Our first light ray. It's coming and going to hit here. This is interface. This line is interface. Here, this side, air is there, inside. That prism material is there. That may be glass. Okay. That's why it is interface. This is point of incidence. This light, it got normal incidence. That's why this light keeps moving along that path only. This light. Yes. Now this light is in which medium? It is in denser medium. It got incident here. This is interface. This line is interface. Inside a glass there. Here above that line air is there. That's why this is interface. Now this light got incident here. To that point again we have to draw a normal. Yes, this red colored line is normal to this point of incidence. Now you see, this light is coming from denser medium and it bounced like this. Yes, it bounced back to the denser medium only. Came like this, bounced like this. Here that TIR phenomena got takes place here. Light ray came from denser, bounced back to the denser. Here it is the TIR. Yes, now this light ray, it is coming like this and it going to hit here. Here. Yes. Again this is the interface. Inside glass there. Here air is there. So it is interface. Now this light ray got incident here. To that you should draw normal, I mean perpendicular line to this surface or to that interface. You have to draw a perpendicular line. This red colored line is normal to that point of incidence. You see here, this light is in, I mean it is coming in or coming through denser medium, and again this light is bouncing like this. It coming like this and bouncing like this. See here again, here also what happening, coming from denser, bouncing back to the denser. Again here one more TIR takes place. Have you understood? Here one TIR, here another TIR. Now this light ray is coming like this and it going to hit here. This is again, yes, this is interface. To this point, this light ray hitting normally. This light, it is going to hit normally. That's why this light keeps moving straight. This is 1 dash. This is 1 dash. See here. This one incident light ray got passed through the prism, and here it got first TIR and it came like this, and here at this point it got another TIR and again it came along this finally. See here, this is 1 and 1 dash. It happened like this. Totally here we achieved 180 degree deviation. Here 90 and here 90. Totally 180 degree deviation in this prism we got. Same thing is going to happen with this second light ray. Same thing is going to happen with this second light ray. You see here, it coming like this and bouncing like this. This is 2. 2. It is coming like this and finally it is emerging out like this. 2 dash. 2 dash. Have you understood what mean totally reflecting prism? It is a prism in which there is a 90 degree angle between its 2 refracting surfaces and the other 2 angles each equal to 45 degree is called as totally reflecting prism. If we prefer that material like this type, then we are going to achieve TIR phenomena. Okay, and even based on their orientation or based on their position, we are going to get 90 degree deviation and even 180 degree deviation, that too because of TIR phenomena. This is the second application of total internal reflection. So now come over here, third application, what we named optical fiber. What mean optical fiber? It is a very important. It is a device. It is one of the material which we using to transmit the light rays along any desired path without any loss in its energy is called optical fiber. Optical fiber means it is a device which we using to transmit light rays along any desired path, along any desired, how much you want, any desired path, but without any loss in its energy. That's we call as optical fiber. See its importance. We can transmit the light ray from one place to any place without loss in its intensity, without loss in its energy. That is only because of TIR. Yes, you see here how that device is made. That device looks like a pipe. It looks like a pipe. We call even as optical pipe also. It is a pipe. See, there are two medium. That pipe made by two medium. Inside material, inside one we call as a core. Inner one we call as a core, and there will be a outer medium that we call as cladding. Outer on both the top and bottom surface. Inner one is core, outer means on both top and bottom. Here and here. That we call as a cladding. I mean that optical fiber made with two medium, inner medium, outer medium. They are different medium. Inner we call as core, outer we call as cladding. Yes, see, it is very important. They are different medium, I said. Here, how we made it. See there, very important arrangement is there here inside that. The inner medium, which we call core, has more density. It has more refractive index than that cladding medium. I mean the refractive index of this core is greater than the refractive index of that cladding. Because of this arrangement only TIR is going to take place inside it. This is very important. Have you understood? Ri of core is greater than Ri of cladding. Yes. Now you look here. It is like a pipe. Yes. Obviously that being with one inlet and one outlet. Now you see here what happened. A light ray. You concentrate on this one. This is a light which we pass you inside that optical fiber. Just we going to pass that light in such a way that it is going to experience multiple total internal reflection inside it. Getting what I mean? We are going to send a light in such a way that it is going to experience multiple total internal reflections inside the optical fiber. Mean what? Just have a look on this diagram. See, this light ray we sending with one proper angle. We sending that light with one proper angle. By that angle, it going to get a TIR there. That is only arrangement. See now, look here. This light ray it came like this. Here air is there. When it got incident, this is interface. This line is interface. Yes. Here air is there, their core material is there. When it got incident here, to that point you should draw one normal. Yes, this red colored line indicating the normal. Fine. It moving from rarer medium to denser medium. Instead of moving straight, it going to bend towards the normal because it moving from rarer to denser. That's why instead of moving straight, it bent towards the normal. This is normal. Towards this normal, it bent. Yes, fine. From here, through this core, that light ray is moving. Yes. Through this core, through this same medium, it propagating along this straight line. Yes, it came and it got incident here on this point. Here it got incident. Just look here, this is interface. This curved line is interface. Above this point, cladding is there. Below this point, core is there. Their Ri are different. Getting? Yes. Cladding Ri is less, core Ri is this light ray is moving through denser medium towards rarer medium. Yes, it got incident here. It is moving in denser and bouncing back into the denser. So now this we call as TIR. Here TIR happened. TIR. This light ray moved through denser medium and bounced back to the denser medium. So here that TIR takes place. Yes. Now this light is coming along this path. Yes, through this denser medium again. Yes, it is going to hit here again at this point. See there? Again here this is interface. This is interface. Above core is there, below cladding is there. This light came from denser medium and again bouncing back to the denser medium. DM means denser medium. Coming from denser, bouncing back to the denser. To this point, same analysis. I draw one normal. Again bounced back to the denser medium. Like this type that continuously happening. Are you getting? You see here. Thereafter sending that light inside the core, it going to hit the top surface and the top cladding, bouncing back towards the bottom cladding, again bouncing towards the top cladding. It keeps bouncing like this, like a ball getting. So you see here, even you can see it moving along the length of that optical fiber. At every TIR, its intensity is going to remain same without loss in intensity or energy of that light. We are moving it from one place to another place. That device we call as optical fiber. Have you understood how light is propagating through that pipe which we called as optical fiber? That is because of TIR. Everywhere TIR happening. You see. It came here, it got incident here. Again, this is interface. Again, this is interface here. It moved through denser and bounced back to the denser. You see here, this is denser. Bounced back to the denser medium. And again here, what happened? TIR taken. Here also TIR. Now finally you see in this my respective diagram, what happening? This light ray coming from denser medium and here at this point it coming out through the outlet now. Now it is moving from denser. Here which medium is there? Air is there. Denser to rarer. Instead of going straight, it is moving from denser to rarer medium. Instead of going straight, it bent away from the normal. Have you understood? This is with respect to this diagram. I mean, we entered light through that optical fiber somewhere here and finally we got that light here. The intensity of this emergent light ray and this entered light ray remains same because of TIR, totally reflected. Have you understood? This is called as optical fiber. This optical fiber has more application. This optical fiber has its own very important applications. Because of this, it's a very important work. It has more applications. Like these optical fibers are used in optical experiments and in some medical experiments. Okay, optical fibers are going to use in some optical experiments and even in some medical experiments. And optical fibers are going to use to find the refractive index of liquids. It is going to use to find the refractive index of liquids. And even optical fibers are going to use to transmit or to receive the electrical signals. To transmit or to receive the electrical signals. Then next, these optical fibers are going to use to find the temperature, pressure or flow rate of any liquid. These are going to use to find the temperature, pressure and to find the flow rate of any liquid. And even these optical fibers are going to use to find the blood flow rate. Blood flow rate, what we call BP. These optical fibers are going to use in finding blood flow rate. Yes. And finally, one more. Because of movement of light through that fiber, that looking like shining, because of its brilliance, even this optical fiber is going to use in a decorative purpose, as a decorative lamp. Have you understood? These all are the uses or applications of optical fiber. In exam, even they will be asking, mention few applications of optical fiber. You don't get confusion with applications of TIR and even applications of optical fiber. Optical fiber has its own applications. According to the question, you have to answer. This is about the third application of TIR. Then finally, last one. What I have written here? Sparkling of diamond, or even we call as brilliance or shining of diamond. Why diamond is going to shine? That is also because of TIR. Just look here. I have drawn here one diamond. Okay, this is a diamond. Okay, see here. Now in this, what happening? Why it looking shining? See here. This is a light. Here two mediums are there. That diamond itself made by one medium whose refractive index is more than the surrounded air. Here around this diamond there is a air medium. Okay, and that diamond made of another medium. Their Ri are different. Diamond is denser than the air. Now you see here. This light is coming from air and entering into this diamond medium, moving from rarer to denser. Yes. This light ray got incident here at this point. It got incident at this point. To that point, I have drawn one normal. This red colored line indicating the normal. Okay. Yes. Moving from rarer to denser. That's why it bent. Instead of moving straight, it bent towards the normal. Here normal is there. This light, instead of moving straight, it bent towards the normal because of movement from rarer to denser. Yes. Now this light ray is coming through which medium? It is coming through denser medium. Okay. Yes. It got incident here on this interface at this point. To that point, again you have to draw one perpendicular line which we call as normal. Yes, this is normal. Fine. This is incident light ray coming through that denser medium. Yes, got incident here. What happened? That incoming light completely bounced back along this direction. It bounced back, came through denser medium and bounced back to the denser medium. What happened here? Here TIR happened. To get TIR, light ray should come from denser medium towards the rarer, but it is bending towards the denser medium. This is TIR. Here at this point, TIR takes place. Yes. Now this light coming through this denser medium and hitting here. Again I draw one normal. This light ray got incident here. It is moving through denser medium and bounced back here. This one, concentrate. This one. Again bounced back to the denser medium only. Yes. One more TIR happened here. Yes. Again here. You see, it got incident on this point. Again bounced back. Coming through denser, bouncing back to the denser. Again TIR happened. So what I mean to say here, once light entering into that diamond, thereafter inside that diamond medium, that entered light experiencing multiple TIR. Because of experience of multiple TIR inside that diamond, that light ray moving randomly inside it. See the path of this entered light. It came like this, here, gone like this, again bounced down, and again bouncing up. It moving randomly. Now again it is bouncing back. I mean, once light entering into such diamond material, that entered light keeps moving randomly inside that diamond because of TIR. That's why that diamond light is moving there. Whatever light entered into diamond, it is being inside there only. That's why that diamond looking like it is shining, or it is looking like brilliance. That we call as brilliance of diamond. Yes, the reason behind the shining of diamond is that is TIR. So even that we consider as the application of TIR, that is sparkling of diamond. These four are the very important applications of TIR. In exam, you must and should mention these four. If they ask a question like write any few applications of TIR, it's a very important concept. Now after this, after discussing about the TIR, now we entering into the one more concept. See that we called as spherical refracting surfaces. Spherical refracting surfaces. These are also refracting, but their surfaces are looking like spherical. What means spherical refracting surfaces? These are the refracting surfaces which forms a part of the refracting surfaces, which forms a part of sphere of transparent material, called as spherical refracting surfaces. I mean, the refracting surfaces. See, look on this diagram and go with my definition. Look on these. Anyone, just now look on this. The refracting surfaces which forms a part of sphere, of transparent material called as spherical refracting surfaces. Means what? See here. Look on this curved surface from here to here. Look on this arc. Below this arc you can imagine one sphere. I mean, it is like this. Okay, it is like this. Okay. From here to here. This is a curved surface like this. Okay. Yes. Somewhere here you can imagine one sphere, solid sphere. Of which material? Transparent material. See here. This curve is a part of this imaginary solid sphere of transparent material.